is our last day of new material for Chapter 5. Okay? We have our review that we started on Wednesday, 5.1 to 5.4. Those answers are posted online, okay, in last night's homework area. This just says answers for 5.1, 5.4 review, so you can check it there. I won't be collecting it until Monday, and the reason why is Monday is our first day of review, and any questions you need help with on that 5.1, 5.4 review will be going over on Monday in the first 15 minutes of class. Then after that, we will do a worksheet that I had for my ELK time on points of concurrency. We'll kind of go through and that'll be like a self-quiz. What do you know? What do you remember? So make sure you're ready because you want to be 100% on that. Okay. And after that, it's working on your review, getting your note card ready. You've had your note card information since last, I don't know, Tuesday, Thursday, okay, this past week. So you can start getting it ready. Do not try to prep the note card for this chapter test the 5 minutes before the test. You might as well just throw your test away and say, boom, just give me the F. Okay? Make sure you know what's going on with it. I've had some really incredibly wow moments when people have done that. And I go, dude, seriously, you were warned. Okay? So make sure you get that benefit, use the benefit. Get your note card ready. When you do that, you're getting to know material better. Okay? So here's the day. The last new material for Chapter 5. Apply inequalities and two triangles, okay? And we're going to be working with that range of possible values with those two triangles. Then we have hinge theorem, the converse of the hinge theorem. And we're going to check our green sheet. That's that inside the notes packet on just the back because it has all the topics covered in Chapter 5. And I want to see where you're at with the things you know and the things you feel like you have to seek out extra knowledge or perhaps read with a little bit more intent on fulfilling the things that you don't understand. Okay, and that's just inside that green cover. So we're in the objective to apply inequalities in two triangles. So theorem 513, the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle and the included angles are not congruent, then the longer third side is opposite the larger included angle. Okay, then the longer third side is opposite the larger included angle. Okay, so now here's the deal. Yesterday we learned about the relationship between angles and the sides of a triangle. Okay. And we talked about those skills. We couldn't extend outside the triangle or a triangle connected to that triangle. Today, with hinge theorem, which is side angle side inequality, we can do that. We can compare triangles that aren't connected. Okay? We can compare the size of angles and the size of corresponding sides based on the information given to us. But we have to pay attention to it, and it's all about us reading diagrams again. So before we start going on about this next problem, I want you to make sure you change this. That should be MN, not MA. There is no A in those two diagrams, and I apologize for that mistake. There's another one that we're going to correct here, so I think I probably did this late at night, and that's where it was. But now, here's the thing. What's this mean? Hinge theorem is side angle side. Now, the two sides have to be congruent. Please notice that AB and XY are congruent, and please notice that AC and ZY are congruent. Those have to be fixed. But then the angle value is variable. It gets to change. Okay? They're not the same. And this is how we can use the hinge theorem. We're asked to conclude, knowing that angle A is bigger than angle X, we look at it and we can say, hey, because angle A is, that BC is across from angle A, BC is bigger than the segment across from angle X, YZ. And we can say that in our conclusion. Okay? Now, keep in mind, every time we learn a property, we learn about the converse of that property. So we're going to see this converse soon, converse of the hinge theorem. But right now, how do we apply it? Okay, so I've got this stuff going on. They got ST and they got MN, and they're saying, hey, which one's bigger? How do we tell? First, we notice the restriction on the sides that make our angles. Okay, once we notice that the same sides make the angles we're comparing, we look at the angle values. 57 is across from MN. 90 is across from ST. And some people go, where did 90 come from, Bloom? So you see that the perpendicular lines make right angles, and right angles are 90 degrees? Well, that's what we're doing. So now we're looking at this, and the alligator eats the bigger side, right? Are you okay with this? I got greater than. ST is greater than MN. Are there any questions how I make that determination or how I came about it? It's a use of hinge theorem. So don't come unhinged. Okay? Thanks for paying attention. Okay, so you guys got the turn. In B, you're doing kind of the same relationship, but keep in mind, everything we've learned to this point is fair game for you to have to use to apply the hinge theorem information. So first of all, BD is congruent to itself, reflexive. AD is congruent to DC. What in the heck is that angle? Is it 0? What is that angle? And how did you find it? Say it louder. How did you find it was 93? Has to equal 180. They're supplementary. 87 and that 93 has to be 180 because they're a supplementary angle pair. Awesome. So this is 93 degrees. We're applying hinge theorem. 93 is opposite AB. 87 is opposite BC. So I'm looking at, or BA I should say, the way they've asked this in the problem. So which one's bigger? Which one's the alligator going to eat? Are you okay that it's going to eat BA? And it's because that's across from the 93 degree angle. So it's going to eat BA. BA is bigger than BC. Okay. Now, we use supplementary angles there. Look at C. Can we use supplementary angles here? Okay, the big thing, I got about a bunch of head shakes here on campus. And the big thing about this is that I've got an angle that is not coming in on the side. If this was a straight segment, then maybe we could talk about, hey, they're supplementary, we could subtract and it's on 103, but it's not. So I don't have any information here. I'm really clueless about that angle value. I have no idea. Although I have fixed sides, I have that reflexive property and everything else. So I have to write no conclusion here as my answer. Okay? Are you all okay with the reason why I'm doing that? Head bobbles? Going back and forth? Okay, so let's look on this next section. I would like y'all to answer problem 2. Go ahead, read it, check it out, see what you know. Now, here's the deal. A crocodile opens his or her jaw. I don't want to say that the male crocodiles have big mouths either. Okay, it's equal across the board. Crocodile opens their jaw, let's put it that way, at a 30-degree angle. They close the jaw, then open them again at 36 degrees. In what case, or which case, is the distance between the tip of the lower jaw and the tip of the upper jaw greater? AKA, which case had a wider mouth opening? Yeah, 36 degrees, bigger angle, opposite the bigger opening. That's it. by side angle side inequality. Now, I'm going to have you take that same type of information to the clock. And to help us out, I'm just going to kind of make up a clock here. So give me a moment to kind of get my clock on. Okay, because I got one, to save us some time, we'll clone it. Maybe it'll let me clone it. Okay, so we got it cloned. I have one time at 2:20. I have another time at 2:25. Okay, just to give you a visual of what we're asking to do. At which time is the distance between the tip of the hour hand and the tip of the minute hand greater? 2:20 or 2:25? 2:25, because why? It's open wider in that time. Even though the minute hand's moved along a little bit, it's still open wider in that 5 minutes. Now, I want to ask you that question this way. What if I say 7:20 and 7:25? Which one is it this time? So which one's open wider? 7:20, right? Weird, right? Depending on how I position the clock and the hands. But in the question itself, the 2:20 was greater. 2:25, excuse me, was greater. But you got to make sure you're careful. MCA does these weird things with clocks all the time. I mean, it's not all the time. I guess every couple years or so I hear kids talking about a clock problem and that. And I'm always curious about that because there's so many people with digital clocks, and I'm just as guilty. I grab my phone and it's a digital face. So I'm just wondering just how antiquated our hand clocks are. Mod 60 counting. But that's the question. We got an answer. I gave you another possible with it. So we're going on, and we're looking at this. Probably the hardest stuff I've got today. Okay? So we got this idea of hinge theorem, right? So you got your thinking cap on, because this one's tough. I want you to consider that we must consider the smallest angle value, which is 0, and the largest angle value that we're studying this year, 180 degrees. Okay? These are possible angle values that we can work with. That's the smallest and the largest, those two extremes, okay? And I'm going to tell you how we're going to use them. But before we start with that, I want to talk about how I can tell which of the provided angles are bigger than the other using hinge theorem. So really what I've got this and this, they're congruent, and then they share a common side between them. So it's totally going to work out that I'm using hinge theorem. Which side is longer, CD or CF? CD or CF? CD is this side, CF is this side. Which one's bigger? And why? Why is it CD bigger than CF? It's got a bigger number. It's that direct. Okay, so CD is 23. You know what that means to me in this problem? 75 is the bigger angle, right? Because 75 is across from the bigger side measure. Okay, so we got some head stuff. So here's the thing. I'm going to set up a range. And that range, biggest value is 75 on the right. Okay, but the smallest value, what's the smallest that other number could be? That other angle that's not 75. The smallest it could be is 0. Okay, so I have a range between 0 and 75 with x minus 13 in between. Now remember, 75 is the largest angle because it's across from the largest, longest side that we're comparing. Okay, that's why I'm able to set up what I did. Now, once I do the setup, I'm taking my picture, my diagram, and putting it from geometry to algebra land, right? So what I want to kind of wonder about with y'all is, what if it was just that? How would I solve for x? Do you remember doing inequalities? I mean, do I do really anything different with them other than, you know, when I multiply or divide by a negative, I got to switch the sign? I mean, other than that, I got to just solve the way I've been the whole time. So I've got x minus 13. So I just add 13 to both sides, right? To get x by itself. Does that make sense? All right, so you ready? You ready? Keep your eyes open. I don't want to shock you. How would I solve that? What would I do to get x by itself? Yeah. Same thing, right? Weird. So let's do this. Let's multitask. Let's add 13 to each part of this inequality. Okay? I'm going to add 13 here. I'm going to add 13 here, and I'm going to add 13 here. Since I would have done it separately, right, for them, I could do them together. These should be the same answers. So I get to be getting 13x 88 when I get those things done. Are you okay with me adding 13 to both, or all three? What we just found are possible values for my x in my angle provided, okay? When I consider the smallest possible angle I could have is 0, and the largest is 75, okay? Now what I'd like you guys to do is set up the next one, and it's a very similar setup, because that's what we do. It's a we do, and then you do, and we talk about it. Okay, so let's do the you do. Go ahead. You do that voodoo so well. Let's get it done. You guys got B. Setting it up in a very similar fashion. And if you're a little sketchy about it, just do the setup, because that's the hardest thing right there. Once we get to the setup, life is good. We're in algebra land. Algebra land is fun. Now, hopefully you see that 36 is the largest angle in this relationship because it's opposite 50. 2x minus 16 is the smaller angle. It's opposite 49. Okay, well, I'm going to set it up, and 0 is my smallest because I have to have a bottom. I have to have the absolute bottom considered. Okay, so I'm getting a range of angle values. Are you okay with what I've done? Go ahead and go for the solve. See what you got. Go for the solve. See what up. Remember, you solve it the same way you would any other equation we've done. We got inequalities, so the only difference is when I multiply or divide by a negative, I got to switch the sense of the sign. But in this case, I don't have to worry about it because I'm not going to be dividing or multiplying by a negative value to get it done. Mr. Stroud. Yes, you will need to, but you first make sure that you add 16 on both sides. Excuse me, sir. Sorry about that. How'd you do? Thumbs up, thumbs down, thumbs to the side. Not sure. Up, getting it. Side, kinda, but down, no way. Come on, evaluate yourself. See what you got. Okay, I got some slanty thumbs. That's good. Slanty uppies. I like slanty uppy thumbs. That's good. All right, thanks, guys. Now, you're doing the same thing in problem C. Go ahead, give it a try. Not all the time. I'm going to talk about that in a second here. The first number is not always 0. Unfortunately, Bloom just picked 3 examples where the largest value wasn't the actual number, so we have to consider what it would look like to have the biggest one be 180. And we'll see what that restriction looks like. Okay, so this next one in C. We're looking at this restriction. I've got 4y minus 5 across from 4. I got 43 across from 6. 43 is the absolute largest one we've got going on, so I got that going on. Okay? Does that make sense? Now, with that said, I've set up 3 problems where the number inside, the angle inside, is the largest. Yet we know that the largest possible angle could be 180. So how could we use 180 in these? Okay, and hopefully you guys noticed as you went through, you got this solved. I'm kind of rushing off on that example I want to talk about. Or maybe not. So we got 5/4 less than y less than 12 because I'm dividing by 4 across. Okay, when we're done. So are you okay with getting to this solution? Now, let's talk about what would it look like if I had to change. What if this was 55? And let's just change this to green because I'm going to say a what if. What happens if I had to change it? What is now the smallest angle? Do you see that 36 becomes the smallest one? It's an actual number. 36 is now the smallest angle. So let's talk about 36's smallest. And it's smaller than 2x minus 16. So now, is 2x minus 16, can it be any value? What's the most extreme restriction we have to set on angles that we're learning or studying this semester? Because we've gone from 0 to 180, right? So that's where the 180 comes in. I can't have it be any bigger than 180. Does that make sense? So that's where we have the extreme be 180 or the extreme be 0. You guys saw 3 extremes being 0. And I'm just showing you an example that you may see something like this on your assignment where you have to consider 180 being the largest. Okay? So just know that that might be a possibility. Okay? But after you consider that and you set it up, it's Algebra Land City. Okay? So just know that, and I'll erase that so it's not too confusing to cover that what if. Okay, rolling on. Just like any other time we've done stuff, we have the original, and now we have the converse. Before we get to the converse, though, we got to make a change. And I'm going to talk about why this change has to exist. Okay, and you got to make the change when you do the assignment, because I think I use the same thing on the assignment. You ready? Do you see those? What's those 2 arrows mean on those lines? Parallel. Okay, cool. Now, because of that, I've got a transversal coming down. What do I know about these 2 angles? What type of angles are they? Yeah, Shroud. Alternate interior. Fantastic. Alternate interior angles and parallel lines are congruent. Look at the value on your diagram. Oops. It says 44, right? It should be 45. Let's make it 45. Okay, there's a whole list of reasons why I've got to keep it 45 versus doing something else, and I hope you guys will start recognizing why. Now, because I've made that change, we now have to include the possibility that we use an equal sign, okay, for this next problem. But before we get there, now that we've changed it, I want to talk about the converse of the hinge theorem. Remember, this is a side-side-side inequality, okay? And go ahead, let's get this going. The converse of the hinge theorem states if 2 sides of one triangle are congruent to 2 sides of another triangle, then the third sides are not congruent to each other. Then the larger included angle is opposite the longer third side. The larger included angle is opposite the longer third side. It's just the converse of what we just did. Okay? So they're connected. So now, knowing that, please answer all those questions in 5. You know, all those, really hard, nasty questions, and consider them. Go ahead and do 5A, B, and C. Go ahead, get them done. Now, hopefully, things are going okay. But let's talk about them as we look. We've got POQ. POQ is 45 degrees. MON is also 45 degrees. So we've got these as equal. Okay? Now, once we get that, we got MN and PQ. MN, PQ. And since, now, here's the thing. In order for us to make these comparisons, although they are across from 45-degree angles, we got to make sure that it's hinge theorem we're applying. So I want to point out something that I know about this triangle. Do you notice what type of triangle this green triangle is? Say that again, louder. It's isosceles. How did you figure that out? Yeah, the base angles are congruent. So therefore, these sides must be congruent. And it's a right isosceles because of that 90-degree angle. So now I know that I can compare MN and PQ. And now we know that they're equal as well because they're across from 45-degree angles because of alternate interiors. Now I'm looking at MP and OP. MP happens to be the hypotenuse of that right triangle, and OP happens to be a leg of that same right triangle. And because one's the hypotenuse and one's the leg, I know that the hypotenuse is bigger, but more specifically from yesterday's class, the length MP is opposite the 90 degree, and the leg OP, or the side OP, is opposite the 45. Since 45 is smaller than 90, OP is smaller. Okay, and that's what we should do. Now, what I'd like you to do in this next one is consider which position should be the answer, and then go ahead and consider problem 7. So read it by yourself as I read aloud. In the diagram at the right, in which position are the tips of the scissors farther apart? And why? Position B, are you okay with the fact that the angle in position B is bigger, so the tips should be farther apart according to hinge theorem? Okay, then that's the deal. This next question is very much like an ACT, SAT, MCA test type question. Okay, they'll do this type of stuff to you. They'll ask you questions about isosceles, equilateral, talk about some sort of other theorem, and then expect you to do something like, in this case, perimeter. Okay, so as I'm considering that, I want you to think about the picture that might come out of this. Okay, I've got an equilateral triangle, all the angles inside are the same, therefore all the sides are the same. Connected to an isosceles triangle. I decided to connect them, I didn't have to, okay, but I just decided to draw it connected. When I'm looking at this, I have these sides fixed. They're the same, okay? Matter of fact, if I put numbers to them, all of them say are 10. So the thing that would make it different would be whatever this is, because if these are 10, these are 10, these are 10, this is 10. So I'm looking at ABC being 30, okay? So really I'm wondering if this is something that's fixed, and this is 60 and this is 65, which one's bigger? The one across from 60 or the one across from 65? According to hinge theorem. This should be bigger because it's a bigger angle, okay? And because perimeter is adding all three sides together, and the equilateral triangle, they're all the same size length. The isosceles triangle, the base side, is larger than the equilateral triangle side, so therefore the isosceles triangle with a 65-degree vertex angle is a longer side, and the difference in the perimeter is determined by comparing the sides across the 65 and the 60 angles. Okay, and that's where I'm getting it. I have 3 questions left for you. As you guys are doing this, I'm going to hand out your assignment for today. You are comparing in those 3 questions the 2 angles above, and you're trying to determine which one of them the alligator will eat, which means you're setting up an inequality statement. okay, or a statement of inequality with those two angles in each one of the 8A, B, and C. Okay. You ready? You're making the ooh, let's not do that. You're making comparison there. See how fast you are at home and get those answers before you can try them. Okay. Stop the video really quick. Okay. Write an inequality relating the given angle measures. If there is not enough information to reach a conclusion, write no conclusion. Okay. Remember, you're checking out. I actually tell you, check out measure of angle A and compare it with the measure of angle F. What do you know? The measure of angle L and compare it with the measure of angle R. And then the measure of angle MLN and the measure of angle ONL. Check them out. Okay? To quote a famous American, how you doing? How's it going? Scale of 1 to 4, just go 1, 2, 3, or 4 in front of you. Remember, 4 is like, we'll move over. I'm teaching this. I get it. Okay? All right? Okay. Thank you. Thank you. Thank you. Thanks for doing that, guys. I appreciate it. Remember, if you got questions on anything, make sure we start talking about it. You can even re-see these videos. I know. Joy. But keep in mind, you can speed me up and I sound like Mickey Mouse. So that's pretty cool. Okay. All right. So I hope things are going well. Remember, the test is next week. We got 2 days left of review. And we're off and done with Chapter 5. We're doing Chapter 6. I even have the Chapter 5 retest stuff posted in class. So we're ready to rock and roll this sucker. Okay, so know that I'm all ready for the retest. I'm hoping that I don't have to do that for anybody because you all are doing your vocab, you're all asking questions and following up so you can be successful so you don't have to worry about doing that because the retest has to happen before we leave for break. Okay, in that 7 days before we rock. And you'll know your answers to your test are right or wrong Thursday, the next day after the test. Okay? All right. Hope things are going well. You guys have a great night.